Hi, this is Karen O'Brien, and I'm going to do a quick video on how to set up a spillway. I'm going to use two separate methods. One will be to manipulate the elevation of the levee cutoff directions, and the other method will be to create a hydraulic structure to represent a spillway. So that's the rating table for this spillway. This is just the Q, the depth on the left and Q on the right table of the spillway, and we can set that up in a hydraulic structure, or we can manipulate these levee cutoff directions because they would also represent weir flow over the dam. If you just lowered them to say the spillway elevation and you chose enough of them to cover the length of the spillway opening. So we're going to, first of all, we have to set up a handful of things. We have to make an assumption that we're ignoring this spillway over here, so we're going to just block it off and ignore it. We're going to define our spillway over here. But our first method will be to set up a hydraulic structure where we want to define our spillway. And in the hydraulic structure, so to set up a hydraulic structure, you come here and you click the Add a Structure button, and then you'll click the upstream node. With a left click, click the downstream node with a left click. That'll be that light green line is our structure. And then you'll click Save. And then when you click Save, it will fill this in with all of the data. So then you'll name it Spillway. Let's just name it Spillway. So it changes the name just so you can see that this is the one we're working on. And it goes from the floodplain up here to the floodplain down here. So it's floodplain to floodplain. We are going to use a rating table. We aren't going to import the table. We just created it in that temporary document file right here. So I just got this from an online spillway calculator, but you probably have like maybe a design of your spillway, or you probably know the hydraulics of your spillway because you already set it up with like a weir calculator or whatever. So you want to use a rating table. That's the key to this. And it always has to start at 0 depth, 0 discharge, and then this is 0.1 feet over the crest of the spillway, and this would be the discharge through the spillway, 0.2, and of course if you're using metric, convert that into metric, and make sure that your final depth and discharge relationship is going to be like slightly above the design of the spillway, so that you make sure you can capture all the potential flow that could go through the spillway. And what we'll do is now these are tab delimited, or you can just put the data right into the table. But these are tab delimited because when I copy this data, and so like if you're copying it from Excel or something like that, that's like perfect. And you come over here and you put your cursor in the first and you click paste, and that pops that data in there for you. And then of course when you reload it, it probably adds those significant digits, which are probably 2. And then another no tailwater effect, right? There's no tailwater effect on a spillway. It's headwater effect only. Then this is 1398 is the crest elevation of our spillway. So until the water surface elevation of our reservoir reaches 1398, 1,398 feet, or in your case, you'll probably be using meters, until it reaches that elevation, or excuse me, until it exceeds that elevation, your spillway won't turn on. All right. So let's so in other words, it's resetting the elevation for the inlet of the structure to the elevation of the crest of the spillway, and then this is the discharge relationship for the spillway. Then you click the schematize button to finalize that and turn it, and that turns the green line into the blue line, which is the FLO-2D data. Now, in your case, you might want to set this up at the actual location of your spillway, and then this would be at maybe the base of your spillway. Probably want to have this next point at the base of your spillway. Just so you know, there's no like velocity or anything computed through this line, between these two cells. It's not like a pipe or a rectangular channel or anything like that. It's just a discharge at this that is transferred to a discharge down here, okay? So if you want something that's going to be calculating the momentum over and down that spillway, FLO-2D is not the tool that you want. FLO-2D is more for using, inundation mapping, not for designing spillways and stuff over dams, okay? Just to let you know. Now let's go ahead. This one's done. So now we have to fill the reservoir with water, right? So remember, when you're doing FLO-2D and you're doing reservoir mapping, you cannot have any elevation up here. So you might have to hollow out this reservoir by deleting out like maybe contours of data out of this reservoir so that you can fill this reservoir with water. Because if it's already filled with water, then your grid element elevation represents the surface of the water, then everything you do to your modeling is like above that condition, above that water surface elevation condition. Just if that's not understandable, just send me an email and I'll, we can take a look at that together. Let's see, so where are we? So we are filling this reservoir node. Let's take a quick look at this. So this is under initial condition editor. And to make one, you'll just come over here and you click the map anywhere inside that reservoir and you set up the name, water surface elevation, check this checkbox, and this, because you don't have tailings, this goes to -1. And if you have, then the notes, I always just say that, -1 means no tailings, just so I remember that. And then you do want to check that checkbox. I'm going to click cancel and revert to saved because I don't want to replace the one I already have. So the reservoir elevation that I have is going to be filled to 1397.9, which is just about 1/10 of a foot below the crest elevation of our weir. So the levee elevation in here is 1401. 1401 is the elevation of the levee, and then we are using a hydraulic structure to represent the elevation of the weir, which is 1398, and our reservoir elevation will be 1397.9, and then we will use the inflow hydrograph to fill the reservoir the rest of the way up so that it will start to flow over the hydraulic structure. All right, so this is the simplest way to set up a weir or a spillway with FLO-2D. Let's go ahead and export the project and run it. So I already did export it, but I don't think we can hurt anything because I didn't really change anything in the data that we just made. So we export and we get these files. Let me show you what we should see in our files now, just because we want to check them. So in flow.dat, we have our reservoir right here, and we have a, I'm giving us 200 cubic feet per second steady state, starts at 0, goes up to 0.1 hours and 200 cubic feet per second, and then all the way out to 10 hours and 200 cubic feet per second. So steady state hydrograph ramping up over 1/10 of an hour. And I'm sorry, I know you're probably doing metric, but this is cubic feet per second. So the 200 doesn't matter. In your case, this would be like your flood hydrograph, or maybe you're using rainfall or something like that, and that's perfectly fine. Okay. Oh, also I did not use that ponding end value in there, so we don't need it this project. But if you're having any instability issues or any volume conservation issues, be sure to check that checkbox for the end value for your reservoir. All right, now where were we? We were gonna run it, right? No, we're gonna look at the data. Still looking at the data. So highstruct.dat, you can see that this is just the time on, or excuse me, depth on the left, discharge on the right of our structure. And this is the head reference elevation where the structure will start to flow. So the water surface has to get up to that elevation before the water will start to flow. Levee.dat, one of the things I want to do is just make sure that everything is a greater than 1401. So we come in here and I looking to make sure that everything is greater than 1401. Okay, I see one right here that's a little bit off. So I'm going to put that to 1401 and then maybe go see why that one was off in the code. So save that and close that. That one is set up correctly. I don't know why that one was 14.0 or was less than 1401, but let's not waste your time on the video because your levee is probably set up correctly. Let's go ahead and just continue on with the demonstration. Now we got to run it, right? So I'm going to just click this guy right here and then I click OK. And if it doesn't start running, like it might give you an error message, just review the error.check and it'll tell you what's wrong with it. Usually it's something to do with your levee, like one of your levees is underground or something. And now it's starting to fill up. And then once it fills up over that 1/10 of a foot, that 200 cubic feet per second is filling the pond. And then once it fills up, it will start to flow. And then I think you would probably need to run it a little bit longer than 2 hours to get that steady discharge of 200 cubic feet per second through the structure. Because I didn't get that, so probably I need to let it run longer than 2 hours because it's a bigger pond and it takes a while for that water to distribute and fill that up to the correct elevation. We're going to let it run for 2 hours. We don't need to let it run any further because we see that it's working, and then we'll shut it down just to check the hydraulics through the structure. Should be just about finished. All right. And I'll close that. And now, no, well, I guess it doesn't matter. We can just use this one. I forgot what I was doing though. Let's see, we wanted to, oh, I know what we're doing. So if you're using build 22, sorry, I need to get that off the ID tool. It's driving me crazy. There, and we'll close the ID tool. Okay, if you're using build 22, you might be able to use the hydrog program to plot the discharge through that structure. So you might be able to do that. So I'm going to try to plot hydraulic structures and let's just see if it works. Okay, yeah, so this is the discharge through our hydraulic structure. And as you can see, it gets up to about 160. So it probably needs a bit more time to completely fill that reservoir and really start flowing through that at time. So there is a bit of a delay from the rainfall and the hydrograph entering the pond and filling it and then causing it to spill over and overtop. And that's, you should expect that. Now, if you don't have build 22, if you're using build 21, perfectly fine. It's perfectly fine to be using build 21, but you can't see that data in struct.out using hydrog. So instead, you'll just come here to hydrostruct.out and open it, and you can see your discharge through your structure, through your spillway, right here. This is called hydrostruct.out, as you can see from right here. Okay, so getting up to about 169 and still rising, so needed to run it longer to really get that full flow through there, but looks like it's working fairly well. Okay, so that's the easy way to set up a spillway. Now let's move on and we'll look at a little bit more challenging. First off, let's turn our hydraulic structure off because we want to just use this next method. We'll just be using the levee. Now, I'm also going to turn off the hydraulic structure just so we don't have to see it. So that will be this one. Also, I don't need that to be in editing mode, so I'll just stop that in editing mode. And this one. So now we are kind of focusing on our levee. So for my levee line, I just want to show you this process. So now I have a levee line to set the position of the levee. So when you utilize a levee line, be very careful not to snap it to the corner of a grid, because if you snap it to the corner or possibly even the edge of a grid, you'll get a calculation error and your levee cannot proceed because it can't the algorithm cannot define where to place the cutoff direction, because it has to be approximately toward the edge of the grid element or toward the corner of the grid element, not exactly on the edge or the corner of a grid element. So just be careful about that. And as you can see here, I blocked off that spillway because we want to make a spillway right here, just to show you the process. So I had to block that one off so it wasn't accidentally spilling it. Now, when you set up a dam or a levee with FLO-2D, the levee, these little red cutoff directions must be higher than the ground elevation, or you'll get an error, because FLO-2D cannot calculate levees that are below the ground elevation. So you'll automatically get an error for those. So what I did here is I put in some elevation points, and I want to show you the elevations of these points. So I'm going to turn on the labels for those, double click, and let's just oops, sorry, I didn't want that. I wanted labels and single labels, and we'll use the elevation as our, okay, great. So now you can see that this one is 1408 because one of these, the elevations over here was higher, was about 1407 or point something. So I just needed to get above that. This one is 1401 because the crest of this dam is 1401. And this one is 1401, and it ties into the location where the elevations start getting higher than 1401. So let's use the ID tool, the grid ID tool, just to study that a little bit further. So here's my grid ID tool right here. And so I'm going to click. Let's take a look and just study this for a minute. So this grid element, I'm clicking. Let me turn off this guy for a sec because it's just kind of there. This grid element is 1404.5, 1408.4, but there's no cutoff right here. So we don't have to put our levee higher than 1408. This one is 1407. That's why we put this cutoff. That's why we started this cutoff at 1408. So this starts at 1408 and goes, and it interpolates as it goes along here. It interpolates down to 1401. So if this one, when I first started this, I think I had it set at like 1406 or something, and it was wrong. So I've just bumped it up artificially to 1408. This one was 1401. So this is an individual line. It could be the same line. It kind of doesn't matter, but I just wanted to show you that this is an individual line and this is an individual line, and they share this point right here. They could be the same line. That doesn't matter, but of course I'm going to take that out. So that's why I made it its own line, because, you know, it's not real. It's just for the purpose of showing you this video. And then this line here starts at 1401, goes 1401. So these red ones are getting 1401, 1401, 1401 as you go along here until it gets right here. And then right here, we want to change that levee from 1401 at our spillway down to 1398 for these 5 cells, 1, 2, 3, 4, 5, because what I want to do is I want to simulate a 100-foot long levee. My grid cell size is 50. So that means that each of these are about 0.41 or 0.42 times 50. So these are about 20 feet long. And so we want about 100 feet to represent the crest length of our spillway. So we need about 5 of them. So let me go here and select 2 of these points. I'm going to select this layer and open the attribute table. And then I'm going to select these 2 points. See, I selected that one and that one. Those are the ones called spillway. I'm going to edit those. I'm going to set the crest elevation to 1398, and I'll click Update Selected, or you can just do it straight in here. That works too. And then, of course, now I need to click Save, and then I can turn off the editor. Don't worry about this. It doesn't work, but I'm going to go ahead and take it out because it's not right. I was trying something else. I was trying to set it to 1401 and then just drop it 3 feet, but that, for whatever reason, that system didn't work. So I'm going to ignore that. Then I click save, and then I turn that off. And it's very important that those points all say Levee. So when you're building those points in that file, elevation points, you'll edit, create a point, and of course your point is going to go along the line. I'm just going to put one right here just to show you the process. I'll put one right here, and we'll call that 1401, and make sure you set it to Levee, and you click OK. And that's how you make one of those elevation points along the levee. And then when you're ready to create your levee, I'm going to, just for the sake of showing you how the levee works, I'm just going to delete this levee right here real quick. I'm going to delete the schema layers, the schema levee. You don't have to do that because the command that writes the levee, it basically just replaces the schema levee. But I wanted to delete it just so that you could see what the model does. Excuse me, not the model, what the plugin does. So here we have the levee elevation tool, and we do not want to use polygons, so we're going to turn those off. And we do want to use user elevation points within a search radius, and we're going to use a search radius of about 5. So that means that it's going to search for points from within this layer along this line that are within 5 feet of the line. And we're also going to use levee line. So again, the levee line defines the position of the levee, and the elevation points define the crest elevation of the levee. And so we'll click schematize, and I'm going to click yes because one of them was a duplicate. So it's going to delete the cutoff with the lower crest elevation. And it was probably right in here. It was probably right here was the location of that duplicate. And then I don't know if you've ever seen this error before, but this error comes up every once in a while, and it says select all from user polygons where membership equals all or membership equals levies unable to open database file. Well, we turned the user polygon off, so maybe that's why it gave us that error, but either way, the calculation worked correctly, so I'm going to ignore this message for now. I'm not going to worry about that message. And we are going to now zoom in and use the ID tool. This will be the regular ID tool. And we're going to identify our levee crest elevation. So this one, and what I want you to do is just pay attention to this number right here. So that's 1401, 1398. Sorry, let me zoom in a bit better. 1398, 1398, 1398. And again, we're looking right here, 1398. And this one I think will be 1399. So if you wanted that to be 1401, you might want to move this point a little bit closer to this point. But 1399 is fine because our spillways is defined perfectly. It doesn't matter. Now, what we have is approximately 100 feet of exposed levees here. And now I will just leave that ID tool alone, and I will turn it off so that we can get rid of that red stuff. And this is going to be a little bit different. So let's, oh, I think we had one cell in there that was a little funky. It was giving us a weird value. So we'll need to be careful, make sure that, I can't remember what, well, we'll pay more attention to it this time. So let's see, now we just, oh, reservoir didn't change, inflow node didn't change. The only change is that it's going to now spill over the levee. So let's go ahead and export it again. We'll call it spillway test. We'll just replace the other one. Again, we don't have any rainfall, so we'll just don't have any hydraulic structures. We'll just click OK. And let's go ahead and click run. And just make sure it starts running. And Let's just check it because something might be wrong with it. No, it ran. Oh, perfect. Okay, it stopped it just right. So minimize that. And while it's running, let's take a quick look at the new levee.dat file so that you can just go down here and find those other cutoff directions. Okay, here they are. So 1398, 1401, 1398, 1398, 1398. Well, and don't worry, this is just a funky, the way that it's written is just a little funky, but they're perfectly fine. So there's only 1, 2, 3, 4, 5 cutoff directions that are given 1398. And let's go ahead and take a look at our run and see how it's spilling over the levee. And it's a little bit funky because when now it's physically spilling over the levee, but these two velocity vectors are a little bit funky because those are the levee cells. So levee cells, the velocity vectors probably are not accurate. And there you see that you have that. And click OK. And how do we tell how much water spilled over that? We might be able to pick it up from this floodplain cross section. So again, back to, I'm sorry, I don't want to run it. Sorry, excuse me. Back to the drop down button, run hydrog. And this time, instead of using the structures, we'll go floodplain cross sections. And this does work with build 21. And you see, same thing, it's about 162 and still filling. So it's almost exactly the same discharge as that weir discharge that was calculated via the hydraulic structure rating table. So that's great. Anyway, so I hope this helps. I will stop the recording. And of course, as always, if you have any questions, go ahead and let me know with some pictures and stuff in email, and I'll hopefully get this out to you today.